Hi class, welcome to our lesson, lesson 4, solving equations with fractions. And I know there's a little Patrick over here crying because I know how much everyone hates fractions, but I'm going to try to make it a little bit easier for all of us so that we don't hate them as much, okay? So, by the end of this lesson, you will know how to get rid of fractions in order to get whole numbers in the equations, right? You'll know how to solve equations that have fractions by using that method that I had above. And then last but not least, you will not cry every time you see a fraction. This is actually not a learning goal. I'm just trying to make you laugh. So let's get started. When we have something like this, we have 1 over 3x is equal to 4. It is actually the same way. It's the same thing as writing x over 3 equals 4, right? And the reason that is because if you have 1 over 3x, right, you basically have 1 over 3 multiplied by x over 1. Then you just multiply the numerators, multiply the denominators. Then you have something like that, right? So if we were going to look at how we would solve this equation, I'm just going to go in and I'm going to write, okay, so we have x over 3 equals 4, right? And if I wanted to solve for x, right, I'm going to want to get the x by itself, so I'm going to want to get rid of this 3 at the bottom. And how I'm going to do that, it's x divided by 3, so I'm just going to do x multiplied by 3 because it'll cancel on this side. And then whatever I do to one side, I have to do to the other, so I'm left with x equals 4 times 3, which is just 12, right? So how I would do this, I would multiply by the denominator to get rid of it. So we're going to do this with this equation over here, and I'm going to kind of do it two ways. So the first way you could do this is that you could go through and you could say, okay, 3x divided by 7, I'm going to move the 1 over 4 to the other side, you know, do all of that. So let's do it the way that traditionally we would approach this. So I'm going to do 3x divided by 7 minus 1 over 4 equals 2. Right? First things first, I want to get rid of that 1 over 4, so I'm going to minus 1 over 4 on both, or add 1 over 4 on both sides, right? Because negative and positive, right? So then I'm left with 3x over 7 equals 2 plus 1 over 4, right? And then, because it's plus 1 over 4, I got to change this 2 into something that I can use. You've got to give it a common denominator. So 3x equals 2, I can change into 8 over 4 to give it a common denominator, because it's just 2 over 1, right? Over 4, 1, right? So then I'm left with 3x over 7 equals 8 plus 1 is just 9 over, and then we leave the denominators the same, 9 over 4. Then I'm going to want to get rid of that 7 at the bottom. I want to get rid of the denominator, so I'm going to multiply by the denominator. Let's go up. I'm going to do, okay, 7 times 3x over 7 to get rid of that 7. So I'm just going to put this in a different color. 7, right? Whatever I do to one side, I have to do to the other. So it's going to be 9 over 4 times 7 over 1, right? And so then I'm left with 3x, because these 7s will cancel out. 9 times 7 is 63. 4 times 1 is 4, so it's 63 over 4, right? And then I want to divide this by 3 to get rid of the 3 in front of the x. And I'm just going to write it as divided by 3 over here, right? And then, so I have x equals 63 divided by 4 divided by 3 over 1. I'm just going to put it over 1 for simplicity's sake. When you're dividing fractions, you're going to change the sign, flip the fraction, right? So I'm left with 63 over 12. And if I divide both of these by 3, I'm left with 21 over 4. Right? You could have also just done this. 63 divided by 3. I know 63 divided by 3 is 21. I know 3 divided by 3 is 1. So 1 And 4 times 1 would have been 4. Okay? All right, and that's my answer. So I know my answer is 21 over 4. This is a lot to do. So we often ask ourselves, what if we didn't have to change this? What if we changed this equation, right? And right off the bat, did something so that we didn't have fractions to work with and we just had whole numbers, right? So that's what I'm going to teach you how to do today, because I know how much you hate adding and subtracting fractions. We have to get common denominators to do that. Then we got to go in and multiply and divide fractions, and it just gets messy, right? So when we're adding and subtracting fractions, we need something that we call a common denominator, right? So the numbers at the bottom need to be the same. For solving equations with fractions, right? So what you can do is, instead of going through all of this garbage that we went through, right, we can just make them all have common denominators and get rid of the fractions, period. And how you can do this is the steps that you can follow, right? The first thing you're going to do is you're going to multiply. I'm just going to write these out. So you're going to multiply every term. And I say term, even if it's not a fraction. Even if it's not a fraction. And that's important, because you can have whole numbers and you still need to multiply them by what we call a common denominator. And we'll do this step by step with our example from above. Okay? Then you're going to cancel out the denominators until they are all 1, right? So you're going to cancel out denominators until all your fractions are over 1. So the bottom number will be 1. So we'll just have whole numbers. Then you're just going to solve with the new terms. For the unknown. And then you're going to state. Okay? So this is a lot. Let's just do our first example together, right? So that you understand what this actually means. So step 1, it says multiply every term, even if it's not a fraction, by a common denominator. So we're going to just go back to our original question, which was 3x over 7 minus 1 over 4 equals 2, right? So now let's go back and look at what's a common denominator here. We have 7, we have 4, and we have 1, right? Because the 2 is over 1. Something that's a common denominator between all of them would be common denominator equals 28, right? So now what I'm going to do is I'm actually going to go back and multiply every term by 28, right? So let's do that. So I'm going to rewrite this out. So I'm going to do 28. And every term is just anything that comes before a plus or a minus sign, right? So 3x over 7 minus, so then we got to put in a 28 here, 1 over 4 equals, and that's a new term, 28 times 2. So notice how every term is now multiplied by, oops, sorry, that should be 2, sorry, 28 times 2. Every term is multiplied by 28, right? So now what we're going to do is we're just going to go in, right, and solve. We're just going to go in, solve, cross out cross out any numbers that we need to cross out, right? And then we'll go from there. Alrighty. So here I have 28 and 7. So I know 28 and 7, right? So if I did 28 and 7, I know that 28 divided by 7 is going to be just 28 divided by 7 should give us 4, right? So I'm just going to do that. 4. And then 7 divided by 7 is just 1. So we'll leave that. 28 divided by 4, right, is going to give us 7 and then 4. This is just the butterfly method, which is why I had told you originally to learn that method, because it's really, really helpful when we're going through stuff like this in class. Okay? And then, last but not least, you just have 28 times 2, right? So let's go and do this. So we're left with 4 times 3x over 1 minus 7 times 1 over 1 equals 28 times 2 is just 56, right? These over 1s means that we can just get rid of the denominators at the bottom. Now, this is so much easier to solve, because then you just have 4 times 3, which is 12x, minus 7 times 1, which is 7, equals 56. And then this is just a repeat of what we were doing yesterday, right? Take the 12x minus 7. We want to get rid of it, so we're going to add 7 to both sides. Right? 12, make sure that the x stays there. 12x equals 56 plus 7, which is 63. Right? And then 63 divided by 12, x is equal to, and then you're just going to reduce 21 over 4. See how much time we just saved instead of having to get all of this and do all of this up here. So this is just a way for you to reduce those fractions, get rid of the bottom numbers, and then make your equation easier to solve moving forward. Okay? So let's go ahead and try a few examples together. So we'll do example 1 together, A, and I want you to pause this video actually and do B, C, and D on your own. And the reason I say that is because it forces you to go through those lessons and go through those answers by yourself, so that when we take it up, you can see where you made your mistakes, right? So let's do this one together. So we have 2x plus 1 over 3 equals 5. Common denominator here, really easy. It's going to be 3, right? Because that's just 5 over 1, and then you have 3 and 3 at the bottom. So let's go back in, and I'm going to write this in. I'm just going to write it in black and give myself some space. 1 over 3 equals 5. I'm just going to go multiply every term by 3. So 3 here and 3. Right, so here I have 3 and the 3, they just cancel out. I'm left with 1 and 1. These cancel out. I'm left with 1 and 1. Right, so 1 times 2x over 1 plus, and you don't have to do this. This I'm just doing to show you where all my numbers are going. Divided by 1 equals 3 times 5 is 15. So I'm going to make sure, and it's important that you do that. You make sure you, even the numbers that are not fractions, you have to do this with. So 3 times 5 is 15. So then, because these are all over 1, I can just rewrite them as whole numbers. So it's 2x plus 1 equals 15. So let's get rid of the 1 on this side by subtracting 1. And then we're going to subtract 1 on the other side. So 2x equals 15 minus 1, which is 14. And then I want to get rid of the 2, so divide both sides by 2. X is equal to 7. Okay? So try doing B, try doing C, and try doing D on your own. And then for part D, check your answer. Make sure that you got it right? And then what we'll do is I'll have you pause this video, and then we'll take it up together. So pause this video and then come back and watch it when you're done. So I'll give you a second. Awesome. So hopefully you actually listened and you paused the video. So let's go and do B together. So here we see we have 4, 2, and 9. We have to find the lowest common denominator between the three. So 4 and 2, you know the lowest common denominator is 4. But between 4 and 9, I believe the lowest common denominator we can get here is going to be, and I write it as LCD, is going to be 36, right? So that means I'm going to go and multiply every term by 36. So let's just write out the terms first. We have 3 over 4x minus 1 over 2, and I'm just going to give myself a lot of space so that I can write this stuff in. 1 over 2 equals 2 over 9, right? And I'm going to go in and I have to multiply on both sides of the equation because whatever I do to one side, I have to do to the other. So that's another common mistake a lot of people make. They only multiply on one side. You got to multiply on both. And now I'm going to say, okay, what's 36 divided by 4? 36 divided by 4 is going to give me 9. 4 divided by 4 is just 1. 36 divided by 2 is going to give me 12. 2 divided by 2 is just 1. 36 divided by 9 is going to give me 4. 9 divided by 9 is just 1. Right? So you're going to divide the 36 or the denominator in front with what the denominator is at the bottom there. Right? You're trying to cancel out the denominators. So now I'm left with 9 as a coefficient because I still had 9 left over times 3, right? All over 1, so I'm going to leave it, and it's 3x. I need to make sure I write 3x. Minus 12, which is the coefficient that's left over there. And then my number here was 1, my numerator, equals 4, right? Because that's what was left over, times 2. Right? And it's all over 1, so we're just not even going to bother writing the ones in. So let's go in and just simplify this. 9 times 3x is going to give me 27x. So I'm just going to write that in, 27x. 12 times 1 is just 12, equals 4 times 2 is 8, right? Did I really say 36 divided by 2 is 12? I'm sorry. This should be 18. So if you're looking at me like, Miss Singh, what are you doing? It should be 18. Oh, you're right. So that should be 18, right? So, because 36 divided by 2 is 18, right? And then we're just going to move this over. We're going to say, okay, 27x. We want to get rid of the negative 18, so we're going to add positive 18. And we're just going to do whatever we do to one side to the other side. So I got to add positive 18 over here. So I have 27, because that's what I'm left over with, right? Negative 18 plus 18 is just going to be 0, right? And that's going to equal 8 plus 18, which I believe is 26, right? And then I'm going to divide both sides by 27, because I want to get rid of the 27 in front of the x. And it's multiplying right now, so it's going to be left with x equals 26 over 27. And you can't reduce that anymore. So you have 8 plus 18, 26. And that's your answer. X equals 26 over 27. Okay. Moving forward, let's go and do C. So if we have C, we're going to do n over 2 minus 1 plus n over 5. And you need to remember that this 1 plus n is in brackets, right? Minus equals negative 1 over 2, right? So I'm just going to go in and be like, okay, what's my lowest common denominator here? Looks like it's going to be a 10. Something that both 5 and 2 can go into. So I'm just going to go in and multiply every term by 10. And I'm going to start going a little bit faster. So please, if you feel like I'm going too fast, go in and pause this video. You're more than, that's why I make them. Right, so I'm just going to go in and multiply everything by 10. You need to remember that this is in brackets. 10, right? I'm going to go cross. 10 divided by 2 is 5. 10 divided by 5 is 2. 10 divided by 2 is 5. Right, so I'm just going to go write this in again. 5 multiplied by n minus 2. And you need to make sure that you keep the brackets intact. So it's 1 plus n equals 5 times negative 1. Oops, I'm just going to put that in the black marker again. Times negative 1. And I'm just going to go simplify. So I'm going to do 5 times n is n. you got to distribute this negative 2 in. So negative 2 times positive 1 is negative 2. Negative 2 times n is negative 2n equals 5 times negative 1 is just going to give me negative 5, right? Collect our like terms. 5n minus 2n is going to give us 3n, right? Minus 2 equals negative 5. I want to move the 2 to the other side, so I'm going to go in and add 2 here, add 2 here, right? So I'm left with 3n equals negative 5 plus 2 is going to give us negative 3. So if I want to get n, I divide both sides by negative 3, or sorry, positive 3. So n is equal to negative 3 divided by 3 is just negative 1. So that's my answer. And then moving on to D, right? We have x plus 3 over 4 plus x over 2, x plus 1 over 6. Lowest common denominator here is 4, 2, and 6 can all go into 12, right? So this is kind of just like, I know this, right? You just need to think, okay, what are the factors of 4? So there's 4, 8, 12, 16, blah, 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 blah. I know 2 is going to go into 4, so 6 is the one that I really need to worry about, and I know that 6 also goes into 12, so I'm going to do that. Okay? So I'm just going to go back and write this in. X plus 3 over 2, and you need to remember that this x plus 3 is always in brackets. Plus, this is also in brackets because it's the numerator, right? Plus, and I'm just going to give myself a little bit more space to put in my denominator, equals x plus 1 over 6. So I'm just going to go in and throw my 12 in there. So then we're going to start crossing stuff out. So 12 and 2 cross out, I'm left over with 6. 12 and 2 cross out, I'm left over with 6. Oops, and this should be a 4. So not 6, I'm left over with 12 and 4. And if I cross that out, I'm left over with 3, right? And then 12 and 6 cancel out, and I'm left over with 2. Okay, so then I have 3 times x plus 3, right? And the 4 is just a 1, so we leave that. We don't need to write it over anything anymore. 6x equals 2x plus 1. And then this is just like yesterday, right? Where we did, or our last lesson rather, where we just distribute the 3 in. So we're left with 3x. 3 times 3 is positive 9. Plus 6x, distribute the 2 in, 2x plus 2, right? Let's go collect our like terms. We got a 3 and a positive 6, right? You're going to add the coefficients together, so that's 9x plus 9 equals 2x plus 2, right? Let's get rid of the 9, so we're going to minus 9 here, right? So I'm left with 9x equals 2x plus 2 minus 9 is going to give us 2 minus 9 is negative 7, right? So negative 7, just collecting it here. So I'm left with 9x, and I want to get rid of the 2 now, right? Because I want to move the 2 over to the other side, so I'm going to do minus 2 on both sides, minus 2x, because 2x minus 2x will give us 0. Minus 7, so this will cancel. So I'm left with 9 minus 2x, which is just going to give us 7x, right? Equals, and I'm just going to make it so that all my 7s look the same. Negative 7 is what's left over there. And I want to get the x by itself, so I'm going to divide this side by 7, divide this side by 7, and I'm left with negative 7 divided by 7 is x is equal to negative 1. And that's my answer. Right, so you want to make sure that this is correct, so let's check our answer here. We're going to say x is equal to negative 1, right, and you're just going to plug it in. So put in negative 1 plus 3, and I'm always going to put it in brackets. because that's just how I do, right? Divided by 4 plus negative 1 over 2 equals negative 1 plus 1 over 6, right? So then let's just go in. Negative 1 plus 3 is going to give us 2 over 4 plus negative 1 plus negative 1, we'll just make this into a minus 1 over 2, equals negative 1 plus 1 is just going to be 0 over 6. Right, so let's do this. Leave the 2 over 4 as is. Change the 1 over 2 into 2 over 4. 0 over 6 is just 0. So 2 minus 2 is 0 over 4 equals 0. And 0 equals 0. So this is true. Right? It was just we did a quick left. Instead of doing the table, I had done it the other way, but this is left side, this is right side. Okay? And that's our answer. So if you could, please just do your exit ticket number 2 and upload it to your portfolio. So we're going to be using portfolio more often with this unit, right? So upload this to your portfolio. Alrighty. See ya.